Welcome to the second part of this video. In this video we are going to create the component that allows us to switch between a mesh and its associated textures at runtime. If you haven't watched the previous video, please do so. It will help you get started with this one. So as a quick recap, let's look at what we did earlier. We created a renderable mesh component. This actually draws the mesh to screen together with material. In this case, that's the pig head mesh together with the object material. And what we want to do with our component is switch this mesh at runtime and override the texture input of the material as well. Back in Visual Studio, I'm going to add my component to my module. So I will select my module and create a new item. And this will be an knob component. And we'll call this select mesh component. And we'll store that in the source directory of our module. So my first project, module, source, same place as our resource. Here we go. Let's quickly look at this component, and every component consists of two parts. You have the resource part, that's select mesh component in this case, and we have the instance part, and that's select mesh component instance. There's a lot more information available on the difference between the two, and I highly recommend looking at the online documentation that's available. But for now it's good to know that the select mesh component, that's the resource part, that's something you add and edit in Napkin. But when the system encounters this resource, it will create an instance for us, and it will create the select mesh component instance. So this is the part you'll use an interface with at runtime in your code, and this is the part you'll declare in JSON. I know this sounds overly abstract, so let's work out an example and hopefully it'll make more sense afterwards. This component allows us to select a mesh and one of the textures associated with that mesh. And we already created a resource that defines what mesh has what textures, so we need to include that over here. So we'll include model textures resource.h. Now we need an array of those, so I'm going to create a vector of type resource pointer, remember that one, and this will be a model textures resource, and we'll call that models. We also need a default selection index for the model and the texture, because when the application starts I wanted to select the right model and texture immediately. So I will add those now, and this will be model index, and the default is 0, and texture index, that's also 0. Next we'll have to expose these as class members, so we can edit them in Napkin or in JSON. So again, RTI property, we'll call this models, reference to our select mesh component, models, and this is a required property. And this will be the model index, and this will be the texture index. And these are not required properties. So that means that when you forget to actually declare those in JSON, it's fine because they have a default value of 0. Before we compile and add this component to our entity, we need to add one more property, and that's a component pointer. The component pointer allows us to actually link to a component in our scene and use it at runtime to set some of its variables, for example the speed, but in this case the actual model it draws to screen. To set up a link we need to include component pointer, and we also need to include the component it links to. So in this case that's a renderable mesh component. Now let's declare the component pointer. And renderable mesh component. And let's add it as a property. So I'm just going to copy this over. And it's a required property. Okay, great, that should be it. That's the entire resource part of our component. Let's compile our project and launch Napkin. And let's add it to our model entity. And we'll call this select model component. And over here you see the properties we just exposed. So in this case we want to link it to the model renderable mesh component, which is this guy. And we can also add the various models that we defined earlier to this component. So we want to render the pig, we want to render the box, we want to render the sphere, and we want to render the plane. Great, that's all set up. So when Nub now loads this file, it will create a select model component together with its instance, and we'll call update on it. But let's see if this actually runs. Yeah, it runs, it creates the component in the background, but at the moment it doesn't do anything. So I'm back in Visual Studio. I already closed Napkin, and the first thing I want to do is resolve the component pointer in my instance. So I'm going to use a component pointer instance for that. Component instance pointer, and we'll point it to the renderable mesh component as well. And we'll call this a renderable mesh component. And this will point to, and we'll actually have to reference the resource part here. So that is the select mesh component and renderable mesh component. That needs to be a reference. Now this looks complicated, and that's because we're not dealing with default resources here. We're dealing with the instance of a resource at runtime. And that's why we need to resolve the pointer this way. So this ensures that we get access to the instance part of the other component when we set up the link. At runtime we need to access and update a couple of variables. So I'm just going to add those over here. So int and current model index. It's current model index, int and current texture. Now, we also need to have access to the array of models, so that would be a model texture resource pointer and models. And this one I'll explain later, an array of renderable meshes. Okay, time to add the interface for this component. So you want from the outside to, for example, set the current model, set the current texture. You also want to know how many models there are, how many textures there are for a certain model. So ta-da, here it is. This is the interface. It's not worth typing it out together because it's rather straightforward. The only thing we're going to implement later on together is select model and select texture. Now let's implement the init call of our component, and this is called automatically by the resource manager after having loaded the file or creating a new instance of our component. So the first thing to do here is get the resource part. Now let's verify that there's at least one model present in this component, because it needs at least one model to function correctly. And we'll use the arrow state object for that. So now it's time to create a renderable mesh for every model we have, and we also copy the model itself into our models array. We'll use our renderable component, the link we have, to actually create this renderable mesh. And we'll give it a model. It needs a reference. State. Store this. Good. See if it's valid. If it's not valid, we can return immediately. Now let's add it to our models. Oh, our meshes, sorry. And now let's store the model itself. Now what is this renderable mesh? A renderable mesh is a valid combination between a mesh and a material, and a renderable mesh component can create one for us. Basically we're asking the renderable mesh component, hey, I have this mesh and I want to render it with your material. Can I do that? And if it can, we store it. So let's see if this init call works. I'm just going to quickly implement select texture. and select model and compile the project. So putting a breakpoint down, pressing F5. Initialization gets called for us. So the resource is there. We have 4 models and all is well. So we now have our meshes stored, renderable meshes, and our models stored in here. We copy the current texture index and we select our model, which does nothing now. We'll implement that next. First thing to do here is clamp our index, and we'll use our math clamp function for that. And we'll store that in the current model index. Now let's use this index to actually change the mesh. Set mesh. And after having changed the model or mesh, we need to update the texture as well. And that's it. Now let's set and update the texture. So the first thing to do is get the number of textures associated with the current model. We'll do that by using get texture count and current model index. And we'll clamp our index based on that number. And we'll store that in current texture index. The thing left to do is store and set the texture. So based on the current texture index, we can get the texture. So current texture is models, current model index, textures, current texture index, and we need to extract the pointer. Now we have our new texture to set. Let's set it in the material. First, we'll have to extract the material from the renderable mesh component. So renderable mesh component, get material instance. And from this material, we can extract a uniform to set the texture to. And the name of that uniform is the same name as the name in your shader, in this case in model texture. Now let's store that one. And set it to our new texture. Now time to validate our change. I'm going to start napkin here. Start the application. Put it on the right. Select our model component and change the index. Et voila, we can now dynamically update the model and texture associated with that model at a certain index. Wouldn't it be great if we can add some sliders to change the model and texture dynamically? And of course we can, we just have to add some GUI elements. So go to myfirstprojectapp.cpp and in the update call we'll add the first slider. Make sure to include GUI.h and select meshComponent.h. Now, in our update call, after process window events, we'll start by fetching our select mesh component, because that one knows most about which meshes are currently available, how many textures are available, and can also switch them for us if we want. So select mesh component instance and model entity get component, select mesh component instance. Now, after having found that one, we can actually start by defining our GUI, controls, and we need to start making our first slider, and that's the model select slider. Now, in order to do that, we need to know what the current model selection or mesh selection is. So select mesh comp, get model index, and we'll store that. Now, we now have enough information to actually create a slider. So, and that one is select. And if someone drags the slider, we need to update the selection. So select mesh comp, select model. And we'll do the same for our texture. And don't forget to call I'm GUI end after having updated all your GUI elements. With all this in place, let's compile and run the app one last time. And we should see our GUI elements appear. And there we go. I can now select the model using a slider and also select the texture using a slider.